if you just had addition, and if you think about it, numbers, I mean, no one really knows how numbers arose in human culture. There's a lot of speculation and theory, and it doesn't really help to dwell on that, but it would appear that counting came first, so you could keep track of things, and then adding things together would have been the next innovation. Now, you could just have counting and adding for a very long time before it occurred to you to multiply. If you just had counting and adding, there are no prime numbers. The notion isn't there, it just isn't present. Because to have prime numbers, you have to have the notion of divisibility. Dividing a pile of 24 stones into 3 piles of 8. Well, that's just multiplication backwards. 3 times 8 is 24. So you're looking at the answer, 24, and thinking, what times what is that? So if I'm looking at 23 pebbles, what times what is 23? 23 times 1? Well, that doesn't count, because anything times 1 is itself. So it's the fact that nothing times, that no two numbers can be multiplied to make 23 in a non-trivial way, which makes 23 prime. So the act of introducing multiplication brings with it this scatter of prime numbers. Suddenly, as soon as you have this idea of counting numbers, this is the crucial innovation. This is where things go a bit weird. That we've evolved this what I call a cultural operating system, a sort of way of scanning the world, breaking it down into recognisable objects. So, for example, how many people are sitting here in front of me? Well, I have this concept immediately of a person, and I can scan my visual field, and I can separate out the various textures and colours, and see there's a person, there's a person, there's a person, and I can start counting them. Now, that's fine, that works really well if you're counting your children, or your cattle, or pebbles on a beach, or whatever you want to count. But at some point, somebody had the idea of counting numbers, of actually taking this sort of thing that's scanning the world and processing it, and saying, what happens if we turn that on itself? And so we count how many 8s make 24. It's not an 8. I mean, you can count rabbits, you can count pebbles, you can count people, but to count 8s, there's only 1 8, surely, and where is it? So it's another level of abstraction. You're counting numbers, and this led to the partially successful metaphor of feedback.
Yeah. So the idea that multiplication introduces this kind of self-awareness into number, and I think this was the point during the week where there was this first spark where Conrad picked up on this and kind of operated this kind of displacement on it by linking it back to this work you made.
Yeah. I mean, there were two kind of interesting conversations we agreed on. One was the Narcissus thing, and the other one was this piece that there was a brief clip of it in there, which was it was just the thing you've probably all done with a microphone and a speaker. When you put the microphone near the speaker and you get that feedback system where the input is fed back into the output, and it's kind of or vice versa. It's going, and it's so and you get that high pitched squeal. But you can do the same with a video camera and a monitor, and you put the monitor up to the thing, and you can basically get to a certain point. You mount the one in front of each other, and then depending on the angle to the monitor, you can actually create a sort of spiral effect. And then you zoom in, and at a certain point, you get to this sort of event horizon, if you like, where you go to a certain point and it becomes quite sort of shaky. And then it will sort of go into this quite sort of Doctor Who-like kind of sort of gloopy liquid kind of place, which is basically an infinite progression of screens within screens within screens.
The output is being fed back into the input, leading to a really unpredictable, non-linear dynamical system.
But this actually seems kind of extraordinary when you see it at first. But one thing that I think was a really interesting comparison that's just to do with our everyday quotidian experience is that every time you look in the mirror and you look into your own eyes and you perceive yourself, you're standing in front of yourself, like even for the first time as a 5-year-old or 4-year-old, when you have that first conscious moment, it is the same thing is happening inside you, and you're having this where you're perceiving yourself in a mirror. And you're seeing yourself inside you're processing yourself inside your own head, and you have basically a Russian doll going back in infinity of yourself, so to speak, on a smaller and smaller level inside yourself. So it's got that same kind of fractal, kind of repeating kind of thing to this sort of notional idea of this infinite point. And it's sort of I don't know, you can do it with animals and cats and things, and you sort of hope that they're going to have this sort of this epiphany thing when they put, but they just don't. It just doesn't happen. But with a child, what?
Some animals do.
They do, but they don't. They kind of think it's someone else, or they.
No, it's quite.
Okay, well you've got a smart cat.
Some research on
Okay. But there is with children and things. It's one of those sort of first moments, and it's sort of you can link it in with a lot of theories of the origin of consciousness and the sort of myths of Narcissus and things, and it's quite.
Yeah. So we arrived at this notion that multiplication was the narcissism of number.
Yeah, that was one catchphrase.
So in addition to this kind of little bit of magic that happened where there was this sudden connection and the displacement of these ideas which we've been talking about, which were merely a kind of way to metaphorically model something very abstract. And from this developed this model of the way in which number operates on itself as being this kind of video, being able to be figured in a video feedback. And we began to discuss this model, which you can see kind of illustrated on the wall, in which you would see 2 and 3 side by side in addition, and then you would see 3 operating on 2, so as to multiply it.
It might be helpful to draw it with it. I don't know, without the. You should have a place to.
The basic, and this was me trying to. I mean, we're sort of trying to find some point of contact, so I wasn't pretending this was going to be a work of art. This was just me suggesting a physical model that we could start from as a sort of point of departure. So we have some sort of object. Now we were eating a lot of peanuts this week, so there's peanuts lying around on the table, so peanuts became this sort of archetypal unit for the week. But later in the week, Conrad pointed out, well, actually the peanut contains 2. So there's a whole.
It was quite nice because it was this thing. We were using this as an example of singularity, but then of course the peanut is a sort of 2 entities inside the shell. So it's quite nice.
Now, from a pure mathematical point of view, you would just dismiss that. You'd say, well, that's irrelevant. Let's just use a pebble then. But actually, I'm quite interested in this unexpected subversion of these ideas because I'm not a traditional mathematician. But so the idea I was trying to make was that if we put a camera in front of a peanut and split the signal into 2 monitors, then we see 2 peanuts. So this is the act of doubling something. This is the act of 2. This represents 2-ness. Anything you put in front of this, you get 2 of them. And if we put a second camera and we say split that into 3, now we could use any 2 numbers. We could use 29 and 168, but it would be much more expensive to build. So based on the budget limitations, we limited ourselves to the first 2 different numbers bigger than 1. So we had 2 and 3. So these are 2 monitors, these are 3 monitors. So it's a pretty straightforward model. You've got a peanut there, you see 2 peanuts and 3 peanuts. 2 peanuts plus 3 peanuts equals 5 peanuts, wow. But the innovation is, what happens if we move this camera over here? In fact, let's just take this whole thing as a single byte, it's called a complex or an assemblage, and let's just shift it over here. Now the camera is not looking at peanuts anymore, it's looking at the output of this. It's looking at a pair of peanuts as a single thing. So rather than, this represents unity or 1, and these complexes represent the counting of a certain number of something. We move this, at the moment this is counting 3 peanuts. If we move it here, it's counting 3 pairs of peanuts, but the peanuts just representing unity. So effectively it's counting 3 2s. So what we end up with on the screen is 2 peanuts here, 2 peanuts here, 2 peanuts here. And depending on how you set the camera up, you can even get it so that you see the peanuts are framed. So that even though there are 2 peanuts here, you see that they're sort of a dual, the 2-ness of them is preserved within the screen. So this represents the simple fact that 2 plus 3 equals 5, and this represents the fact that 2 times 3 equals 6. Now of course these facts are of no importance whatsoever. Everyone, if that's all we were demonstrating, then the Arts Council probably wouldn't be too happy, but the point is that this is trying to dramatise the categorical difference between addition, where the numbers are playing the same role, and multiplication, where this is playing a very different role from this. This is pointing at an actual thing, and this is pointing at a number.